Good evening, everyone, and welcome to our presentation on DAT and OAT prep. My name is Justine. I'm going to be guiding us through what you need to know about both of these exams, as they are made by the same test writer, and also going over some little tips and tricks that you can use in your studying. Now, I am also joined by my fantastic colleague, Paul. So if you have any questions, concerns as we go, I want you to feel comfortable reaching out to us in this chat. We always make sure in our classes to have an extra, at least one teacher in the room with us. So if you have questions, definitely reach out to Paul here. We've worked together for a number of years. So he's definitely an excellent resource if you have questions. Now, tonight we're going to look at just an overview of the DAT and OAT. These exams are actually very similar to each other. Mainly there's just two sections that differ between them. We'll look at some strategies that you can use really on both of these exams. And then we'll look at some content from the natural sciences. We'll look at some biology and a little bit of chemistry. And we're really going to have a focus on things that you can do to improve your score on these exams. Now, if we look at the DAT, this will start with Survey of Natural Sciences. This covers biology, general chemistry, and organic chemistry in that order. If any of you are taking the Canadian version of the DAT, there are some differences here. If you are taking the Canadian DAT, it is a paper-based exam, and it will not have organic chemistry or quantitative reasoning. You can have a manual dexterity part that is like the soap carving, which is kind of neat, actually. For those of you taking the American version of the DAT, these are all of the sections that you will encounter, and it is a computer-based exam. The Perceptual Ability is the next section after the sciences. This is really testing your 3D reasoning. And it does so in a variety of ways. This is actually one of my favorite sections of the DAT just because it's like really different and it's kind of like a giant puzzle. After that, you'll have a break. I definitely recommend using this time to use the facilities, get yourself a snack, and just do some general stretching and relaxation. Because you still have almost 2 hours of testing with the reading, comp, and the quantitative reasoning. When it comes to the OAT, it's actually a very similar format. You guys will start with Survey of Natural Sciences, but there is no perceptual ability on the OAT. Instead, you all will be taking a physics test. When it comes to the math, I just want to be clear about this. There is no calculus on the DAT or OAT. That's true for the quantitative reasoning. And for those of you taking the OAT, the physics is algebra-based, so there is no need to worry about any calculus at any point in studying from either of these exams. The main thing you want to focus on is, of course, making sure you have the content down, and really the best way of learning content is a mix of just review, and that can be from reading, doing flashcards, but also practice. From my experience working with students, one of the most challenging aspects of these exams is the pacing. There's a lot of questions for you to work through, and there's not an overly large amount of time. So you do want to make sure that you're giving yourself adequate practice in doing full-length exams. Most students will do a few full-length exams to get to their desired goal score. So I always tell my students this, don't delay practice for later. You definitely want to start doing practice questions early and often. That way you can start to perfect your strategy and also diagnose your weaker areas so you can be more strategic in how you allocate your time. Now, when it comes to approaching questions and this is true for every section, the application of this strategy does differ slightly from section to section, but it's still the same general strategy. What you want to do is to first stop and characterize your answer choices. So what I like to look for is, do I have any kind of like parallel structure in the answer choices where it's really easy for me to just identify the task of the question very quickly? Do I have numbers? And if I do have numbers, do I have units? Because that can allow me to determine, how much calculation I'm going to have to answer the question. And because here's the kicker. When it comes to the quantitative reasoning section, you will have a calculator. And it will be essentially the numerical keypad of your keyboard. So you can type in stuff into that calculator. It's through the testing interface, and you got it. But when it comes to the other areas of the DAT and OAT, you do not have a calculator for Survey of Natural Sciences. And for those of you taking the OAT, you do not have a calculator for the physics. So, two things then. Number one, make sure you review your basic math. Because I know a lot of us have become very dependent on calculators in recent years. So you want to start to remove that dependency when you're doing practice questions, put the calculator away, do stuff by hand. The second thing is that you probably don't want to start with those questions first. So you can do the questions within a particular section out of order. That's what we call triaging, making a decision to be smart about how you take an exam. So don't start with the questions that are really time intensive, that are really challenging. Start with the questions that are really easy, that you can answer really quickly. That's going to allow you to get ahead in time, and then also allow you to build confidence and get points. So don't do the questions in order. Start with the fast, easy questions first, and then come back for those more challenging questions on a second pass. The other thing I want to point out is that there is no wrong answer penalty on the DAT or the OAT. So there is never an opportunity for you to say, I'm going to leave this question blank. Definitely make sure that you have every answer bubbled in, because even if you have no idea, it's still a 20% chance that you will guess correctly. So no question left unanswered. Now, when you see a question and decide you want to do that question, you're going to think. This is where you're going to identify the task of the question and determine what information you need. And mind you, yes, you will get a calculator during quantitative reasoning. Remember, this is a calculator that is built into the testing interface, so you will not have the opportunity to bring in your own calculator. So as you're doing practice, I would recommend using the calculator built into like your computer. So you can go through and like type in the numbers. Yes, like Paul's saying, it's on screen. So don't use your own calculator in practice. Use something that's computer-based. So we want to identify the task of the question. It can help to paraphrase the question stem, write down what you're looking for, and then start to figure out what content information you need to access in your calculator to answer the question. The key step next is to formulate a prediction. This is the step that I know I tended to skip before I really took more of a strategic focus on my prep. And it's a step that I see a lot of my students skipping originally as well. The key here is that you want to go into the answer choices with an idea of what you're looking for. If you're the kind of person who tends to kind of waffle between two answer choices, it's probably because you don't know exactly what you're looking for. So if you predict what the answer should look like first and then look at the answer choices, you're going to be able to make faster decisions when it comes to answering questions. So you're putting in a little bit more work up front with your stop, think, and predict steps. But then once you get to matching, you're able to make really fast decisions that are also more accurate. So it is a return on investment with points. So with that, we're going to take a look at some of the content and some practice questions from Survey of Natural Sciences. And this here says on the OAT Survey of Natural Sciences, but again, Survey of Natural Sciences reading comp and the math section are pretty much identical between the DAT and OAT. Again, it's the ADA that writes both tests. So everything that we cover here will be consistent with both exams. So this is really testing essentially general chemistry 1 and 2. So again, this will go from atomic theory all the way up through equilibrium and kinetics. Your organic chemistry will cover both organic chemistry 1 and 2. So I would say like be really good with like your Orgo 1 stuff with substitution, elimination, reactions of functional groups, different types of isomers, structure and properties. For the organic chemistry 2 part, there are a few like special reactions that they test, like Diels-Alder, Wittig reactions. So I'd be familiar with those types of reactions. Biology, I'd say, is probably the most content heavy, really anything on the DAT and OAT. And that's because it covers a very large breadth of biology. So it tests genetics, taxonomy, ecology, some like general behavior, cell bio, a little bit of anatomy and physiology of both humans and plants. So make sure you have a nice foundation base. And honestly, for studying biology, flashcards are pretty awesome at that because it's a lot of just terminology. A lot of terminology. So we're going to look into the biology section, and I will tell you that in recent years, they have kind of de-emphasized anatomy and physiology a little bit. So that anatomy and physiology would encompass both human and plant. There has been a kind of a shift away from human physiology, so I would make sure you're just comfortable with plants as well. Now, what we're going to look at here is the genetics component. We'll look at different modes of inheritance and also how to identify inheritance and predict probabilities based on pedigrees. So we're going to start by looking at autosomal recessive. And really what I want to focus on in these is what you can use to establish proof of inheritance. Because there are certain things that just tend to happen in different pedigrees, and there's also different things that we look for to establish a clear mode of inheritance. Now, whenever we are given pedigrees on the exam, they're obviously not going to give us the genotypes written above each individual. So this is more like here for reference. So ignoring the written out genotypes, I want you to tell me in this chat, how can we identify this as an autosomal recessive pedigree? What here can we use to prove recessive? And as you think about this, let's just do a quick review of pedigree terminology. So anytime we're looking at a pedigree, males are denoted as squares, females are denoted as circles, because women have curves. Anyone who is affected will be a filled in circle or square. And anyone who is unaffected will be a blank circle or square. So what we want to look for in autosomal recessive pedigrees to establish proof of this mode of inheritance is generational skipping, where we have the trait not appear in one generation and essentially appear in the next. Another way of saying this is we want to look for a mating in a pedigree in which we have 2 unaffected parents that have affected offspring. Now, like, both of them don't need to be affected. And Shoshana, so not all the kids are affected, so therefore is recessive. You don't have to have all of them affected for it to be recessive. In fact, if you have a dominant inheritance, not all the children will be affected in that case either. Because in this case, it's about a 25% probability that any one child will be affected from these parents. When it comes to dominant, it's about like a 50-50. But in either case, it's very unusual to have like all of the children affected. So the key here is we want to look for two parents that are not affected that have an affected offspring. That's the proof. That's the generational skip. In this case, both of our parents are carriers. Each one of these parents has a copy of the recessive allele that they can pass on to their offspring. They're carriers because we do not see a physical manifestation of that allele. That's generally true of carriers. We can only have carriers for recessive inheritances, not dominant. And your carriers will always be heterozygous. Oh, Paul, that is a very good point. Yeah, extra digits are dominant. So, and that's true for, and really, like, I love, Paul, that you put that in there. Prevalence does not mean dominance. That is true always. And let's actually take a look at an example of that with a dominant pedigree. Now, what you'll notice about this pedigree is that the trait appears in every generation. And it is actually possible to have recessive inheritances where we have pedigrees where the trait appears in every generation. And it just so happens that, like, if you have just happen to have more affected people in a particular family, absolutely can appear in every generation. So that's never something that we're going to use as proof. So prevalence is not proof of anything. What we want to look for to prove dominant inheritance is this: two affected parents with unaffected offspring. Because let's think about it. If we had a recessive pedigree, if two people who were affected mated, all of their children would always be affected. So all you have is little r's, all you have is little letters. Everybody would be affected. So in a dominant inheritance pattern, by seeing this particular pattern, two affected parents with unaffected offspring, this allows us to say, hey, this is not recessive, therefore it has to be dominant. So a lack of generational skipping does not prove dominance. What proves dominance is two affected parents having unaffected offspring. And it doesn't have to be like both unaffected. It can just be one. The last type of pedigree we have is X-linked. I always remember X-linked is sex-linked. You will not see X-linked dominant traits. You will not see Y-linked traits, mainly because they're exceedingly rare. So these are the three types of inheritance modalities that you can see. Autosomal recessive and dominant, and then X-linked recessive. Now, what do you notice about this pedigree that's different from a normal recessive pedigree? Because we still have the same general generational skipping. If you look, our parents are unaffected. They have affected offspring, so that's proof of recessivity. So we know that this is a recessive pedigree. But there's something very distinct about this pedigree from normal, just autosomal pedigrees. And that's mainly that if you look at the offspring that are affected, it's pretty much all males. And it makes sense if we think about it. Females are XX. We have two copies of the X chromosome. So in order for us to have an X-linked recessive trait shown, we need 2 copies of that recessive allele. However, if you look at males, males have an X chromosome and a Y chromosome, and those encode different genes. So males only can have the dominant copy or the recessive copy. So males only need 1 copy of a recessive allele to show the recessive trait. Males cannot be carriers of X-linked traits. So you have a lot more affected males and females than X-linked recessive. And again, males cannot be carriers. Only females can be carriers. So what we're going to do is what we do in all of our classes is anytime we go through content, we always want to make sure that we can be able to answer questions about this content on the exam. So let's go through some little practice drills. So we're going to look at some different ways that the DAT and OAT can test us on that content. So this is a very common type of question that you can see when it comes to genetics and inheritance. Notice our answer choices here are percentages. So we're looking at some sort of probability. Now, in our think step, we have to identify the task of the question. We're looking for the likelihood that our offspring is a carrier. And remember, carriers are heterozygous. Now, we also have to consider the information that is provided to us. Here we are given a pedigree. Notice the letters used for this pedigree are not X and Y, so this essentially rules out an X-linked inheritance mode. We know that it's recessive because we have a carrier, and we also know the phenotype of the offspring. We know that this male offspring is not affected. So that's a piece of information we'll have to use to answer this question. So we're going to start by making a Punnett square. Here, this is just a typical monohybrid cross. Both of our parents are heterozygous. So we will see that 1:2:1 genotypic ratio. And here we have to start thinking more critically. We know that our offspring is not affected. So we don't necessarily know its exact genotype, but we can certainly rule out some things that it cannot be. So if we know that this individual is not affected, we know that they are not homozygous recessive. So we can eliminate little r as a possibility. They're not a filled-in square, therefore they are not little r. Now at this point, we are not able to distinguish between homozygous dominant and heterozygous, just because all this being not affected means is we have at least 1 normal dominant allele. We don't know what the other allele is. So these other 3 genotypes are all possibilities. We don't have sufficient information to distinguish between homozygous dominant and heterozygous. But from here, we can see that there are 2 outcomes remaining that will give us a heterozygous individual and 3 total possible outcomes. So then our probability would be just 2/3 or 66%. Note that if we did not know the phenotype of the offspring, it would be 50%. So this is the type of question where just based on the available information you have, you can actually get 2 different answers. So make sure you're using all of the information provided in the question stem to answer your question. This is definitely one of the more tricky questions, but notice that by taking a very strategic and organized approach to this question, we're able to nail it. And that's why you want to just not work hard, but work smart on the exam. Let's take a look at a few more questions. Now here we have answer choices that are all different types of inheritance. and we want to identify an inheritance pattern based on this pedigree. Now, in general, if we just look at the individuals that are affected, we notice that roughly equal numbers of males and females are affected. So we know it's not X-linked recessive because that would be mostly affected males. And it's not Y-linked either because if it's Y-linked, there can only be affected males. And again, you're not really going to see Y-linked traits because it's really hard to distinguish between X-linked and Y-linked. And you can't really have dominant or recessive with Y because you only have one copy. So you're not going to see Y-linked stuff on the DAT or OAT. It's mainly going to be autosomal recessive and dominant and X-linked recessive. Now at this point, looking at this pedigree, we don't see either of those like proofs of inheritance. We don't see two affected parents having unaffected offspring. We don't see two affected parents having unaffected offspring. So in this case, we actually don't have sufficient information to distinguish between recessive and dominant. So at this point, we just cannot make a determination. So anytime you're looking to prove without doubt a mode of inheritance, what you have to see are a mating between two parents that have the same phenotype that have an offspring with a different phenotype. In this case, we have an affected and an unaffected, an affected and an unaffected, and that type of mating does not give us viable proof of really anything. So we're always looking for matings between parents with the same phenotype. So let's look at another example here. So we have essentially the same setup for this question, but notice we have a different pedigree. Again, we have roughly equal numbers of affected males and females, so it's not going to be X-linked. Also notice that there is a distinct difference between this pedigree and the last one. Notice our second mating here. We have two parents that are unaffected and they have affected offspring. Those two parents are carriers. This is a recessive pedigree. This is recessive. Now the kicker here is, I know we often say like whenever we have a recessive pedigree, we typically are not going to have as many affected individuals. That is not the case with this pedigree. We have pretty much equal numbers of affected and unaffected individuals. So again, prevalence here does not prove dominance. We actually have sufficient proof of recessivity here. So you really want to focus in on those, like I call them the characteristic matings, those matings between parents with the same phenotype, because that's what allows us to get proof of a modality of inheritance. Let's take a look at another question here. So here we have answer choices that are males and females. We have a pedigree provided. And notice that the question stem actually does tell us the type of inheritance. This is an X-linked recessive trait. Honestly, even without that information from the question stem, based on the fact that all of the individuals here affected are male, and we have that generational skipping, this is definitely X-linked recessive. But this question is particularly asking which of the individuals in generation 4 should undergo DNA-based testing. Now, I want you to think about why we use DNA-based testing. You can tell me in the chat, or just speak it out loud to yourself. What's the purpose of DNA-based testing? Because essentially, there's two ways that we can identify the genotypic makeup of an organism. If it is, this is a recessive trait that we're looking at here, it's X-linked. If we have somebody that is affected, we automatically know what their genotypic makeup is. They have to have the recessive alleles. There's no doubt about that. Now, given that this is X-linked, remember, males only have one copy of an allele, of the allele. They only have one X chromosome. So just by looking at a man, we can tell, are you, do you have the normal allele? Do you have the recessive allele? It's easy to determine just based on the phenotype. So we don't need to do some sort of like fancy DNA test. We have just like look at the person and figure out what their DNA is. We can't do that with females, however, because remember, females can be carriers. We cannot, at least based on appearance alone, distinguish someone who is homozygous dominant from someone who is heterozygous with recessive traits. In that case, we do need a DNA-based test. So for this, we've gone through, we've looked at we've characterized our answer choices, we've thought about what it means to do genetic testing, we've considered what is true of males and females in terms of this genetic makeup and X-linked recessive traits. We know that females can be carriers. That's who we're going to test. So we're going to look for an answer choice that says we only need to test the female, and that's answer choice B. So had quite a bit of information here in this question. Notice we actually didn't need much of the pedigree to actually help us here. Now, the last question we're going to look at from genetics is another probability question, but this also illustrates a really important point about procreation. And that's this: each child that a couple has is an independent event. So what you've had for your first child does in no way impact the likelihood of what's going to be your next child. So for example, if you have a family that has 4 boys and has another child, it's still a 50-50 whether they're going to have a girl. So each procreative event is an independent event. So with that, let's take a look at this question. So again, we have a probability question, and we're looking at the male in generation 4 having the recessive phenotype. So essentially this tells us that we have a recessive inheritance, and the fact that we have affected females will tell us that this is autosomal. But we know that both of the parents are carriers because they already have an affected offspring. So we're going to make that same Punnett square as we made for that first question. It's that 1 to 2 to 1 genotypic ratio. And honestly, I would know that ratio, like, really, really off the top of your head for test day. It's pretty high yield. 1 to 2 to 1. And there's only one way to have a recessive phenotype. You have to have both copies of the recessive allele. So there's 4 possible genotypic outcomes, only one of which gives us the desired. So this would be a 1 in 4 probability. Again, the fact that we had another child that was already affected doesn't matter. Each child is its own independent event. So the next thing we're going to kind of dig into a little bit is the organic chemistry subsection. This is the last section of the Survey of Natural Sciences. In general, if you're thinking about your pacing, for Survey of Natural Sciences, you have biology, you have general chemistry, and you have organic chemistry. Which of those 3 topics do you think is going to take the most time, just in general? Is it going to be bio, orgo, or gen chem? So if you look at it, like, timing-wise, if you were to spend the same amount of time on every question, you'd be looking at around 54 seconds per question for everything for Survey of Natural Sciences. Now, for me personally, I think that, and I know a lot of students agree with us with this, the biology tends to be the faster questions, mainly because you don't have to write out reactions and you don't have to do math. So for questions like we just did, you would be looking at around 30 seconds per question for those on test day. That's going to allow you to get ahead on the timing because it's going to take more time to do Gen Chem questions and Orgo questions. Generally speaking, you're going to spend around 75 seconds per question for Gen Chem and then around 60 seconds per question for organic chemistry. So by getting ahead of the timing up front with bio, you can kind of bank time for those more intensive questions. Now, when it comes to organic chemistry, you do want to be smart about how you study organic chemistry. I've seen a lot of students struggle with organic chemistry because they had teachers that weren't all really great in college. But the other thing I've seen as a main source of struggle is the way that we learn organic chemistry. A lot of people, a lot of students, whenever studying organic chemistry, tend to focus more on memorizing reactions than we do identifying patterns. So whenever you're looking at organic chemistry, a lot of what you're going to see, just based on this, is about 50% mechanisms and reactions. Now, does this mean you have to draw out every single mechanism and know every single step? No, it doesn't. What it means that, however, is that you want to look at common themes in why things react the way that they do. So I really like to look at everything in organic chemistry as a reaction between a nucleophile and an electrophile. So if you identify your nucleophile, you identify your electrophile, you look at your leaving group, if you have one, and you look at your solvent, oftentimes just from those 4 pieces of information, you can make a prediction about how something will react, even if it's something, a reaction you may not have seen before. So when you're going through and studying your OChem, don't just go through and memorize a list of reactions from a piece of paper. Don't just feel like you need to regurgitate things, because again, this is a critical thinking test. You can see reactions you haven't seen before. But you want to be able to use your base knowledge and apply it to new circumstances. And that really comes down to focusing more on general reaction mechanisms than you do memorizing discrete facts. So we're going to look at substitution reactions, and we're going to start by identifying our key players. So in any reaction in organic chemistry, you'll have pretty much a nucleophile and an electrophile. These are very well named for what they are. So a nucleophile is something that is nucleus loving. So our nucleophile will have concentrated electron density. So we can have weak nucleophiles, we can have strong nucleophiles. The strength really comes down to exactly how much electron density we have. Strong nucleophiles will have full negative charges. So things like hydroxide, things like strong bases will be good nucleophiles because they have a lot of electrons. Weaker nucleophiles will have lone pairs and pi bonds, so some concentrated electron density, but not full charges. Electrophiles, on the other hand, are electron loving. So these are electron deficient. Your best electrophiles will have full positive charges. So things like the carbocation, awesome electrophile. Carbonyls, pretty good electrophiles. The more positive charge you have, the more electrophilic you are. And anytime we have something that wants positive charge and something that wants a negative charge in the same room, they're going to react. So nucleophile and electrophile will pretty much always give us a reaction. So we're going to take a look at the two main types of substitution reactions. And honestly, if we look at their names, it can help us to infer how they will react. So when we look at an SN2 reaction, what that stands for is bimolecular nucleophilic substitution. So bimolecular meaning that there are two molecules in our rate determining step. Nucleophilic substitution in that a nucleophile will attack to substitute or replace another entity. The thing that is replaced is the leaving group. It is the group that leaves. Your leaving group will always take with it both of the electrons in the bond that it's in. So in order to have a substitution reaction, you always need a good leaving group. That's true for all substitution, all elimination reactions. Your good leaving groups are generally weak bases. Those weak bases are cool. They're not reactive. They're okay with the electron density they have. Generally, what you want to look for in a good leaving group is something that has a big atom. So if you look at the periodic table, as you go over to the right and down, you get better leaving groups. The other thing you want to look for is resonance. Resonance is a way of spreading out electron density, and generally, the more spread out your electron density is, the more stable your molecule is. So good leaving groups are things that are stable in solution with the electrons that they acquire. You're looking for large atoms or things that are spreading out their electrons via resonance. So that's what you want to look for. Now, in an SN2 reaction, this is kind of what I call like the homewrecker reaction. If you've seen like literally any romantic comedy or the movie Titanic, it's essentially the general plot line that you have. So if we look at an SN2 reaction from the perspective of the plot line of Titanic, we have Rose, who was like the main lead female, played by Kate Winslet. We had Cal, who was like the rich jerk fiance, played by nobody really cared because we all hated him as a character. And in this movie, they were engaged to be married. Now, Cal was kind of like a jerk, but he was really rich. So in the absence of ever meeting Jack, those two would have gotten married. So in order to break that bond, you need an even more awesome thing. So for an SN2 reaction to happen, your nucleophile had better be really awesome. That's why they cast Leonardo DiCaprio for the role of Jack. He is by far the best nucleophile. Now, your nucleophile will have a full negative charge. It's evidence of a great nucleophile. And of course, if you're trying to like form a new bond with someone who is engaged, you're certainly not going to do that like in front of their face. So the SN2 reaction we call the backside attack because the nucleophile always attacks opposite from the leaving group. And then we have this transition state. This is kind of more of a theoretical thing. We cannot isolate transition states in solution because essentially look at this. This is a carbon with like kind of 5 bonds. So this is more theoretical. But essentially, it shows the molecule turning inside out to give the substituted product. So for an SN2 reaction, this is taking 2 to tango, and it's the concerted backside attack. Now, we're going to look at some of the properties of this reaction, including just the general reactants and the stereochemistry, since that is an area I see a lot of my students kind of struggling with. Now, when it comes to stereochemistry, we say it's inverted, but I want to talk a little bit more about what that means. Whenever we say the molecule, like the stereochemistry is inverted, what that's really talking about is the structure of the molecule. So I like to think about the SN2 reaction in terms of stereochemistry, kind of like holding an umbrella in a rainstorm and your umbrella turning inside out. That's exactly what's happening to the molecule. Essentially, it started out like this, and then it kind of flipped around. So the molecule itself has turned inside out. However, the questions on the exam can ask you for an RS designation. RS depends on priority of your groups, not the fact that it's turned inside out. So depending on the actual identity of your nucleophile and your leaving group, you may or may not have an RS swap. So for that reason, when it comes to SN2 reactions, you always want to figure out what your product is. So draw out your product, redetermine the priorities after the reaction, and then make your RS designation. So anytime we're talking about stereochemistry, the molecule turns inside out. R and S may or may not change. It does maintain stereochemistry in that if you have a chiral reactant and you get a chiral product, your product will be R or S, so either one or the other, not both. So we maintain stereochemistry, but we may or may not change RS. And if you have questions about that, definitely reach out, because it is probably one of the most common mistakes that I see my students making in terms of stereochemistry. The other thing to look at are some of the general properties of an SN2 reaction. So when it comes to kinetics, the number associated with the reaction will always give you the order of the reaction. So an SN2 reaction is a second order reaction. Always remember, it takes two to tango. So the rate depends on both the substrate and the nucleophile. However, the substrate, depending on its level of steric hindrance, may or may not be suited. Oh, Simon, that's a great question. You're just starting at community college. All right, so most people will take their DAT after their junior year of college. In general, you can take it after your sophomore year as well. Just, I always say you want to take it when you are ready, once you've had all of your prerequisite classes. So after you've taken, a year of biology, a year of chemistry, and a year of organic chemistry, you're going to be in a pretty good place to take your DAT. Most students will prepare anywhere from 3 to 6 months for their DAT. It really depends on how much time you have available each week to study. So I would definitely get through your prerequisite classes first, and then you can start to think about when you would prep. But if you took it after your, over the summer after your sophomore or junior year, I'd say that would be a pretty awesome time. And if you have more questions, definitely talk more with Paul. And certainly, get you set up with more of a concrete schedule. Now, for substrates, when it comes to an SN2 reaction, I always say you don't want to have a lot of junk in your trunk. So the less sterically hindered your substrate is, the better it will be for an SN2 mechanism. So methyl substrates are the best. They have essentially no steric hindrance because it's just hydrogens, and hydrogens are tiny. Primary is good for SN2. Secondary works. It's not the best. So SN2 reactions with secondary substrates are a little bit slower. Tertiary does not work. There's just too much stuff for the nucleophile to get in. So tertiary will not undergo SN2. Your nucleophile has to be good. Remember, this is your homewrecker reaction. So you're looking for something that has a full negative charge. Full negative charge. When it comes to your leaving group, you always need a good leaving group. So something that is either a large atom or stabilized by resonance. The last thing to consider is your solvent. When it comes to the solvent, your solvent is aprotic. It's still polar because your reactants are either polar themselves or charged. So all substitution reactions will need polar solvents. The difference will be in whether or not they are capable of hydrogen bonding. For SN2 reactions, we don't want anything interacting with the nucleophile. We want it full to go through and attack. So we don't want anything that can hydrogen bond with it. And Mary, yes, nucleophiles can be neutral, but that's not a strong nucleophile. A strong nucleophile will have a full negative charge. Something like water is an okay nucleophile. It's not a great one. So absolutely, your nucleophiles can be neutral. You know, they'd have to have lone pairs or pi bonds, but the neutral nucleophiles are not the strong nucleophiles. So those would not be as suited for SN2. Those would actually be really great for like SN1 reactions. So actually, let's take a look at an SN1 reaction. And we're going to look at some of the key differences. Now, if we come back to that same kind of idea of SN2, where SN2 is like the home wrecker with Titanic, SN1's a little bit different. SN1 would be, instead of having Kate Winslet play the role of Rose, we instead cast Beyonce, where she would look at Cal and be like, you know what, I don't care if you have money, you're a jerk, and I just don't want to be with you, would pack up all of his stuff and kick him to the curb. So an SN1 reaction doesn't need a nucleophile to get itself started. An SN1 reaction essentially starts with the formation of the carbocation. And that's the rate determining step, because this is the breakup, essentially. You kind of got to like build that angst for another human like over a long period of time before you kick them out. So that's the SN1. It's the breakup. Now, after the breakup, we are newly single and generally not as picky. This is like the rebound afterwards. So the whole rate determining step here is the formation of the carbocation. That's what makes it unimolecular, because there's only one entity involved in that step. Afterwards, we're not really in any like hurry to get anything serious. So, you know, the carbocation just kind of dates around a little bit. You know, not as selective since it's the rebound. So we don't really need the best nucleophile for an SN1. Just something that is a nucleophile is sufficient. The other thing to consider about an SN1 reaction and how it's very different from SN2 is the stereochemistry. Remember, for SN2, that maintains a chiral molecule. That's not true for SN1, and here's why. After we have the dissociation of our leaving group to form our carbocation, our carbocation is sp2 hybrid. This is a flat, planar molecule. So our nucleophile can attack from the top, our nucleophile can attack from the bottom with equal probability. So if we do make a product that is chiral, we actually make both enantiomers. So SN1 reactions either will not make chiral products or they will make racemic mixtures. We will not ever get a product that is optically active. It's just not going to happen with SN1. Now, the last thing to consider with SN1, of course, are the properties and how it's different from SN2. Now, given that this is unimolecular nucleophilic substitution, unimolecular means it's first order. It's all about the carbocation. And that also describes why certain substrates work better than others. Because this is all about the carbocation, remember that we became newly single when we formed our carbocation. We want to make sure that we have sufficient like friend stability to keep the carbocation happy. In the world of organic chemistry, that's the R groups, that's alkyl groups. So our carbocation needs to have a lot of friends to keep it nice and happy and stable. So tertiary is like maximum friendage. We're really happy. This is really great for SN1 pathways. Secondary is good as well because essentially you have two hands to hold, you get two buddies. Primary and methyl doesn't really work for SN1. That's just because we don't have enough alkyl groups to stabilize the carbocation. Primary and methyl carbocations are very reactive and thus they do not form readily in solution. So we'll not see those for SN1 substrates. The nucleophile doesn't have to be strong. This is where we can have the neutral nucleophiles, things like water and ammonia. We don't need strong. But we do need a good leaving group. That is non-negotiable for substitution reactions in general. Remember, to substitute, we have to replace something with something else. So there has to be something that we can get rid of. Gotta be. Now, the last thing to consider is the solvent. The way I always remember the solvent for SN1 is stability. Remember, this is the breakup. Oftentimes, there's ethanol involved in stabilization after the breakup. Now, I'm not encouraging that by any means, but it is the way that I always remember that a protic solvent is good for an SN1 reaction, something that is capable of forming hydrogen bonds. So for SN1, we will see substituted substrates, and we don't need to see the best nucleophiles. So hydroxide, we wouldn't have to use hydroxide. This would totally work with water as well to get a product. And in that case, water could act as both the nucleophile and the solvent, which is actually fairly common to see in an SN1 reaction. So let's just take a look at a quick question here just to reinforce this and also look at some other strategies that we can use. Now here we're looking for what is most suitable for SN2. Remember when it comes to reactivity trends that there is that certain ranking as we go from methyl to primary to secondary to tertiary. So anytime you're looking for the most or the least something, you can eliminate the middle answers. So for me, I know these aren't all equally reactive. I would cross that out. And I would get rid of B and C because those are the two intermediates. So automatically, just by a little bit of application of strategy, we can get rid of 3 answers and we're down to a 50-50. At this point, we could look at this and say, well, it's SN2. I know SN2, I don't want a lot of junk in the trunk. This is my backside attack. So I'm going to go with the answer choice that is the least sterically hindered. That is answer choice A. So when you're studying for your DAT and OAT, look for trends. Also, think about little stories you can tell yourself. This is what I love to do in my classes when I'm teaching. Because I always say cheesy makes it easy. So the weirder the mnemonics you can make for remembering content, probably the easier it's going to be to remember that content. The other thing to consider is practice. As you'll see, as I'm sure you have seen, there is a lot of content on the DAT and OAT. And for those of you taking the DAT, there's a lot of strategy to master for perceptual ability. I am not a natural 3D thinker. I, in fact, got lost because my GPS wasn't working today. But I can tell you, still did really well in perceptual ability because it's not about being able to think in 3D for that. It's really about strategy. So if you know that you need to work more on strategic approaches to questions, if you need more practice questions to go through, definitely come talk to us because I do want to make sure that all of you are well equipped to succeed on your DAT and OAT and become, fantastic future professionals. And a lot of that comes down to having the right tools to prepare for your exams. So definitely reach out to us if you have questions. We'll certainly stick around. Otherwise, enjoy the rest of your night and best of luck as you prepare for your DAT and OAT.